Hello, dear students of Third Secondary Language School. I have the pleasure to meet you today to introduce a revision on algebra except permutation and combination. Now, let's go to the first example. Find the square roots of the number z equals negative 8i. Solution. Z equals 8 times negative I equals 8, and negative I means cosine 3 pi over 2 plus I sine 3 pi over 2 equals Z power half equals 2 root 2, which is the square root of 8, cosine 3 pi over 2 plus I sine 3 pi over 2 all to the power half. Then equals 2 root 2 cosine 3 pi over 2 plus 2 pi over 2 over 2 plus I sine 3 pi over 2 plus 2 pi r over 2, where r equals 0 and 1. Then z power half equals 2 root 2 cosine 3 pi plus 4 pi r over 4 plus I sine 3 pi plus 4 pi r over 4. Now put r equals 0. Therefore, z power half equals 2 root 2 cosine 3 pi over 4 plus I 3 pi over 4 equals 2 root 2 times negative 1 over root 2 plus 1 over root 2 I equals negative 2 plus 2I. Now put r equals 1 by applying the Moivre theorem. Therefore, z power half equals 2 root 2 cosine 7 pi over 4 plus I sine 7 pi over 4 equals 2 root 2 times 1 over root 2 minus 1 over root 2I equals 2 minus 2I. Therefore, the two square roots are positive or negative 2 minus 2I. Now, let's go to another example. Find the real values of x and y which satisfy the equation x plus iy all squared times 1 plus I plus 7 minus I equals 0. Solution. X plus I y all squared times 1 plus I equals negative 7 plus I. Therefore, x plus iy all squared equals negative 7 plus I over 1 plus I times its conjugate, which is 1 minus I over 1 minus I equals negative 6 plus 8I over 2 equals negative 3 plus 4I. Therefore, x squared minus y squared plus 2xyi equals negative 3 plus 4I. Therefore, the real part x squared minus y squared equals negative 3, and the imaginary part 2xy equals 4. This is equation number 2. And by squaring 1 and 2, and add. Therefore, x squared plus y squared all squared equals 25. Therefore, x squared plus y squared equals 5. And this is equation number 3. By adding number 1 and 2, therefore 2x squared equals 2, then x squared equals 1, therefore x equals positive or negative 1. Subtract 1 and 3, therefore 2y squared equals 8, therefore y squared equals 4, then y equals positive or negative 2. Then x equals 1 and y equals 2, or x equals negative 1 and y equals negative 2. Now, dear students, let's go to another example. Prove that e power 2 plus pi I minus e power negative pi I equals 1 minus e squared. Solution. Since e power 2 plus pi I equals e squared and e power pi I equals cosine pi plus I sine pi, and this is the trigonometric form instead of the exponential form, equals e squared times negative 1 plus 0 equals negative e squared, and this is equation number 1. And since e power negative pi I equals cosine negative pi plus I sine negative pi equals cosine pi minus I sine pi equals negative 1, and this is equation number 2. Subtract 1 and 2, therefore e power 2 plus pi I minus e power negative pi I equals negative e squared minus negative 1 equals 1 minus e squared. Now, dear students, let's go to another example. Put each of z1 equals 1 plus I and z2 equals 1 minus root 3i in the exponential form, then find z1, z2 in the exponential form. Solution. z1 equals 1 plus I and r1 equals norm of z1 equals root 2 and cosine theta 1 equals 1 over root 2 and sine theta 1 equals 1 over root 2. Therefore, theta 1 equals pi over 4. Then z1 equals root 2 e power pi over 4i. Now, with z2, since z2 equals 1 minus root 3i, therefore root 2 equals norm of z2 equals 2 and cosine theta 2 equals half and sine theta 2 equals negative root 3 over 2. Therefore, theta 2 equals 5 pi over 3. Then z2 equals 2e power 5 pi over 3i. Then z1, z2, the product of z1 and z2 equals 2 root 2 e power pi over 4i plus 5 pi over 3i equals root 2 root 2 e power 23 pi over 12I. Find the value of 5 minus 3 omega squared over 5 omega minus 3 minus 2 minus 7 omega all over 2 omega squared minus 7 all to the power 4. Solution. The expression equals 5 omega minus 3 omega cube over 5 omega minus 3 times omega minus 2 minus 7 omega times omega over 7 omega cube minus 7 omega all to the power 4 equals 1 over omega minus omega all to the power 4 equals omega squared minus omega all to the power 4 equals omega squared minus omega, which is positive or negative root 3I power 4 equals 9I power 4 equals 9, because we all know that I power 4 equals I power 2 times I power 2 means 1. Now, dear students, let's go to another example. Use the Moivre theorem to find cosine 2 theta plus sine 2 theta in terms of cosine theta plus or and sine theta. Cosine 2 theta plus I sine 2 theta equals cosine theta plus I sine theta all square equals, by putting cosine theta equals x and sine theta equals y, therefore cosine 2 theta plus I sine 2 theta equals x plus iy all squared equals x squared minus y squared plus 2xyi. Therefore, cosine 2 theta equals x squared minus y squared equals cosine squared theta minus sine squared theta, and sine 2 theta equals 2xy equals 2 cosine theta sine theta or sine x. Now, dear students, let's go to another example. Prove that 1 plus I all to the power 6 equals 8 e power 3I pi over 2. Solution. X equals 1 and y equals 1, therefore r equals root 2, and cosine theta equals x over r equals 1 over root 2. Therefore, sine theta equals 1 over root 2, therefore theta equals pi over 4. Then 1 plus I equals root 2 cosine pi over 4 plus I sine pi over 4. Then 1 plus I all to the power 6 equals root 2 power 6 times cosine pi over 4 times 6 plus I sine pi over 4 times 6. Therefore, equals 8 times cosine 3 pi over 2 plus I sine 3 pi over 2, and equals 8 times 0 minus I equals negative 8I equals 8 e power 3 pi over 2I. Now, dear students, let's go to another example. Assuming that z belong to C and z bar equals z squared, find z. Solution. Let z equals x plus yi, therefore z bar equals x minus yi, the conjugate. Yes. And since z bar equals z squared, therefore x minus iy equals x plus yi all squared. Then x minus yi equals x squared minus y squared plus 2xyi. Therefore, x equals x squared minus y squared, and this is equation number 1, and y equals negative 2xy. Therefore, y plus 2xy equals 0, and this is equation number 2. And from 2, y times 1 plus 2x equals 0. Therefore, y equals 0 or x equals negative half. And by substituting in equation number 1, therefore, if y equals 0, therefore x equals x squared, then x equals 0 or x equals 1. And if x equals negative half, therefore y squared equals x squared minus x equals 3 over 4. Then y equals positive or negative root 3 over 2. Therefore, z equal 0, 1, negative half plus root 3 over 2I, and negative half minus root 3 over 2I. Now, let's go to another example. The ratio among the three coefficients of consecutive terms in the expansion of 1 plus x all to the power n are 15 to 24 to 28. Evaluate n and find the order of these terms. Solution. Let the three terms are tr, tr plus 1, and tr plus 2. When x equals 1 in any term, therefore the value of the term equals its coefficient. Yes. Coefficient of tr plus 2 over coefficient of tr plus 1 equals n minus open bracket r plus 1 close the bracket plus 1 over r plus 1 times 1 over 1 equals 28 over 24 equals 7 over 6. Therefore, 6n minus 13r equals 7, and this is equation number 2. From 1 and 2, we get n equals 12 and r equals 5. Then the terms are T5 and T6 and T7. Now, let's go to another example. In the expansion of 2x plus 3 over x squared all to the power n, if T9 equals T10 and T7 over T6 equals 15 over 8, find n and prove that there is no term free of x. Solution. T10 over T9 equals 1. Therefore, n minus 9 plus 1 over 9 times 3x cube over 3 equals 1. Therefore, n minus 8 over 9 times 2x cube over 3 equals 1, and this is equation number 1. But T7 over T6 equals 15 over 8. Therefore, n minus 6 plus 1 over 6 times 2x cube over 3 equals 15 over 8. Therefore, n minus 5 over 6 times 2x cube over 3 equals 15 over 8, and this is equation number 2. Divide 1 and 2, therefore n minus 8 over 9 times 6 over n minus 5 equals 8 over 15. And after cancelling or after simplifying, we get n minus 8 over n minus 5 equals 4 over 5. Therefore, n equals 20. Tr plus 1 equals 20 Cr times 3 over x squared all to the power r times 2x all to the power 20 minus r equals 20 Cr 3 power r 2 power 20 minus r x power negative 2r plus 20 minus r. Therefore, 20 minus 3r equals 0. Therefore, r equals 20 over 3, which is not belong to z positive. Therefore, there is or there exists no term free of x. In the expansion of x power k plus 1 over x all to the power 6, where k belong to z positive, find the values of k for the expansion to have a term free of x. Solution. Tr plus 1 equals 6Cr 1 over x power r x power k all to the power 6 minus r equals 6Cr x power 6k minus kr minus r. Therefore, 6k minus kr minus r equals 0. Therefore, k equals r over 6 minus r, and since k belong to z positive, therefore r greater than or equal 6 minus r means r greater than or equal 3. Therefore, 6 minus r greater than 0, and since r smaller than 6, therefore the values of r equals 3, 4, and 5, and the values of k equals 1, 2, and 5. Now let's go to another example. Find the expansion of 1 plus root x power 6 minus 1 minus root x all to the power 6. Solution. 1 plus root x all to the power 6 minus 1 minus root x all to the power 6 equals 2 twice the even terms t2, t4, t6 equals 2 6c1 root x 6c3 square root of x cube plus 6c5 square root of x power 5 equals 2 6 root x plus 20x root x plus 6 square x squared root x equals 4 times 3 root x plus 10 root x root x plus 10x root x plus 3x squared root x equals 4 root x times 3 plus 10x plus 3x squared. Note that 1 plus root x all to the power 6 plus 1 minus root x all to the power 6 equals twice the odd terms t1 plus t3 plus t5 plus t7. Now, dear students, let's go to another example. Prove that a plus 1 all over a plus 2a plus 1 times omega plus a omega squared all to the power 6 equals 1. Solution. Left hand side equals a plus 1 over a plus 2a omega plus a omega squared all to the power 6 equals a plus 1 over a plus a omega squared plus a omega plus omega all to the power 6. And a plus a omega squared equals 0. Therefore, a plus 1 over omega a plus 1 all to the power 6 equals 1 over omega after cancelling a plus 1 with a plus 1 all to the power 6 equals 1 over omega power 6 equals 1. Dear students, this example leads us to the end of our program today, and until we meet again with a final revision on algebra and solid geometry, I hope you all success. Thank you and goodbye.